So previous we discussed the special properties of D block elements. So now one by one we are discussing in expansion mode the special properties of D block elements. So what is the first one? Metallic nature. See, which one you called as metal? See, the substance which readily loses electrons is called as metal. So left to right in period, what happens? IP value is increases. Next, metallic character is decreases. So anyhow, these are showing metals. So metals means what are the properties? They are shining. So metallic luster, that only we call as a shining. Next, they have malleability, ductility. So that means what? They are converted into thin sheets and wires. So that is malleability and ductility. Next, these are showing good conductors. So good conductors of both electricity as well as heat. So that is the metallic properties. Next, these are hard substances. These are also hard substances due to what? Metallic bond. Due to metallic bond. So what is metallic bond? The strong electrostatic attraction between cations and free electron. So that is called as metallic bond. Say number of free electrons are increases. Number of free electrons increases means what happens? So hardness is increases. So hardness is increases. So that is depending upon the number of free electrons. These are happened means number of metallic bonds are happened. The strength will be increases. Next, second property. These have what? Highest melting points. Next, highest boiling points. See, here also, what is that? Number of free electrons. Number of free electrons increases. So then what happens? Metallic bonds are increases. So metallic bonds are increases means hardness is increases. See, not only this metallic bond means attractions only. To remove the attraction, so we must give more and more amount of heat energy. So that only melting point, that also increases. So the melting point mainly depends on the crystalline structure. So it is depending on crystalline structure. See, already your solid state we seen what are that? HCP. So CCP, hexagonal close packing, cubic close packing. So it is nothing but FCC, similar. This is similar to BCC type. Next, if you see, this is what? ABAB type. This is what? ABC type. So continuously. So the different crystalline structures. So that's why the melting point is irregular because of crystalline structures are changes. Crystalline structures are changes means melting points also are observed irregular manner. So irregular in left to right. Suppose boiling points. See, boiling point means what? After become as liquid, so that is further we are converted into vapors. So that same thing also happened. The BP and MP values both are in manner depending on the crystalline structure is melting point, boiling point is depending on the attraction forces. So anyhow, if you take boiling points of 3D series means, so it is observed. So up to vanadium is increases. Next up to manganese, it is decreases. Next for iron, increases. Next further continuously decreases. So zinc. Next here, if you go to the last group elements, so that means so 12th group. 12th group means what? That second B. So zinc, cadmium, mercury. So this is a completely filled electronic configuration 3D10. So because of complete fill up, relaxation came. Relaxation came. Next, number of free electrons are decreases. Number of free electrons are decreases. That means metallic bonds are decreases. So metallic bonds are decreases means these melting and boiling points are low. So because of lowest melting and boiling point, these are called as volatile metals. So volatile metals. Next, that to be. So what is the importance of mercury? So hardness, volatile metal melting and boiling point is decreases means hardness also decreases. So that's why softness is more. So here, next the special important is mercury. So what is that? Due to lanthanoid contraction. Due to lanthanoid contraction, so it is available as a liquid metal. So more and more softness. So free electrons are going inside only. So means lanthanoid contraction. Because of this, the free electron, generally free electrons are not coming. Because of lanthanoid contraction, again the free electrons are decreases. So that become as liquid metal. So because of this. Next, third one, various positive oxidation states. So various positive oxidation states. Where, say, actually this metal means any one of the oxidation state only by showing, but these are very. So scandium, first 3D series you take. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. See, in this manganese, so D block elements, everyone is showing what? +2 oxidation state. Every D block element, general oxidation state is +2. So everybody is showing +2. The speciality is chromium is showing +1. And this is also the possibilities of showing because of what? This is a 3D5 4s1. One electron eliminated, it is stable. Next, this is a 3D10 4s1. One electron gone means a 3D10. So because of that, these are only showing +1 oxidation state. Manganese is showing up to 7. That is the maximum here. Next, remaining elements you continuously decrease. +3, +4, +5, +6. Next, cobalt, +3, +4, +5, +3, +4, +3. Next, here also you decrease continuously. 4, 5, 6. 3, 4, 5. So 3, 4, +3. See, suppose these are showing different positive oxidation states. Because of the d orbital is far away from the nucleus. So because of poor shielding, the electrons are easily coming outside. Next, here we are seeing this much oxidation state. All are not showing. Means some only stable. Manganese +2, manganese +4, manganese +7. These are more stable. Remaining, they are coming in the middle of the reaction and they will go. Suppose you take iron. Iron is showing +2 and +3. These two are very important. What about these three? In the middle of the reaction, these are coming and going. Because of these are unstable, these are stable. they can show different oxidation state in that some only stable. Suppose you take a copper plus 1 plus 2 only showing, but plus 3 it is not stable. So like that. Next, in different elements, they will show some different oxidation state. We must concentrate that also. See, you take 11th group. 11th group, otherwise first B. What are that? What we called as coinage metals. So that is copper, silver, gold. If you see the oxidation state, copper is showing plus 1, plus 2. Lowest oxidation state, cuprous. Highest oxidation state, cupric. Silver is showing plus 1 oxidation state only. Gold is showing plus 3 oxidation state. Next, 12th group, otherwise second B, you called as what? Volatile metals. So what are that? Zinc, cadmium, mercury. Zinc is showing only plus 2. Cadmium also showing plus 2. Mercury is showing plus 1 and plus 2. Mercurous, mercuric. So they can show like this, Cu2 plus 2. Don't confuse, that is cuprous. So Cu plus 2, cupric. Mercurous, Hg2 plus 2. Here, mercuric, Hg plus 2. Different oxidation states. Next, in the total periodic table, the osmium is showing highest oxidation state, that is a plus 8 in osmium tetroxide. So OSO4. Next, in brown ring test, iron is showing plus 1 oxidation state. So wherever the disturbances and deviation, that you must concentrate. Next, another, if metal is combining with mercury, so that you called as amalgam. See, amalgam is what? It is a physical phenomena, not a chemical phenomena. See, suppose sodium amalgam. In the sodium amalgam, what is the oxidation state of sodium? What is the oxidation state of mercury? So they are asking the question. See, here it is what? Just this crystalline structure is enter into this crystalline structure. That is a physical mixing only. There is no chemical reaction. So that's why sodium oxidation state is 0. Mercury oxidation state is 0. You concentrate that one. Next, fourth one. So these are forming a variety type of compounds. That is complex compounds. See, which one you called as a complex compound? So that means this is also a type of salt only. So, but where is the disturbance is happened? See, suppose you take NaCl dissolved in water. So then what happens? You are getting Na plus ions, Cl minus ions. So this is a solid state. This is a solution state. See, normal salts, they can show their original properties in the solid state as well as a solution state. That you called as normal salt. Suppose the D block elements are forming some complexes, some compounds. K4FeCN taken 6. This compound is there. So this is a solid form. In solid form, what happens? It is showing potassium property, iron property, cyanide property. You take into water. So then what happens? You are getting 4K plus ions. Next, FeCN taken 6 minus 4. So the solution state, it will show potassium property. It is not showing iron property. It is not showing cyanide property. So one new property it is coming. So it is dissolved in water. This normal salt also dissolved in water. So same property. So that's why they are thinking that salt is there. But properties are losing. So the salt which has different properties in their solid state as well as solution state, that you called as complex compounds. So the specially these D block elements only readily forming complex compounds. So what is the important of complex compound means that one is important metal, another one is a ligand. Some are surrounded. So which one you add as metal? So the metal features are similar to, that is a D block only. So why these are showing? Next, L means ligand. So ligand. So electron pair donor. Electron pair donors is ligands. So D block elements. What is the D block elements? That has highest positive oxidation states. Highest positive oxidation state means electronegativity increases. Next, they have what? Empty d orbitals. Empty d orbitals. So then what happens? This is ligand is donating pair of electrons, so it has capability to attract electrons. Because of what? Positive oxidation state increases, electronegativity increases, metal attracting electrons, ligand is donating. Next, it is donated pair of electron. Where is the accommodation? So the metal has so many empty d orbitals, the lone pair is coming and occupying the empty d orbital. So that's why the metal and ligand is donating, so you are getting sigma bond. Suppose if ligand also empty boxes, it means empty orbital, so then the metal also donating lone pair to this is a pi bond. So that means between metal and ligand very strengthened bonds are observed. So that's why complex compounds are very stable, and that is the special property of D block elements only. Next, fifth one, interstitial compounds. See, interstitial compounds already we discussed. So here what? Number of free electrons increases. Number of free electrons are increases means metallic bonds are increases. So metallic bonds are increases means they become as crystals. Crystals means what happens? They have close packing. So close packing of atoms. So because of close packing, you are getting some voids. So voids and gaps. See, suppose they are arranged. Already we discussed in solid state the gap. That gaps are what? Tetrahedral voids also there, octahedral voids are there. Suppose these gaps are occupied with small sized atoms like hydrogen, oxygen, nitrogen, so carbon, like that. Small atoms they are occupying. So such type of compounds you called as interstitial. So interstitial compounds. So what is the best example? You take iron, easily rust. Suppose it occupies a carbon, the gaps that become as steel. So what happens? It is not going to rust. Strength also increases. So that means what happens in interstitial, chemical reactions are not takes place. There is no chemical reactions. Only physical properties are increases. Physical properties only changes. So compared to the previous, so their strength will be increases. Say tungsten carbide. Tungsten carbide is more strengthened compared to tungsten. So only physical properties only they are changing. Next, chemically inert. Next, all the properties are same. They can show conductivity. Whatever the general properties of that one, everything it is shown. But only the problem is there is no chemical reaction. Next point. You take a catalytic property. So what is the catalyst? So it is not directly participated in the reaction, but either increasing or decreasing the activation energy and change the rate of reaction. Already in surface chemistry, entire detail we discussed. So majority, all the catalytic is what? D block elements only. Why they are showing D block elements? See, these D block elements speciality is what? More positive oxidation states. That means what? Electronegativity is more. Next, they have so many empty orbitals. So that's why it attracts reactants close. Next, they are easily bombarded and they are, so where these are attracted means the empty orbitals are giving accommodation to them. So after bombardment, the product is forming and it is ejected from the surface. So the catalytic, so here examples only important in the preparation of ammonia. So that Haber's process, what we are using, so that is iron is a catalyst, molybdenum is a promoter we are using. Next, in contact process, you can prepare H2SO4. In H2SO4 also and HNO3 preparation also, we are using what? V2O5, vanadium pentoxide or platinum we are using. Next, preparation of so saturated ghee, otherwise vanaspati. We are using what? Rainy nickel. So that examples are very very important in the examination. So point of view. Next, KClO3 decomposition. So KClO3 means it is a preparation of oxygen. So we are using manganese oxide. So next, you take any organic that catalytes. So catalyst. So many more we can use. So that is what we are using Pattanisapodaro reduction, platinum, nickel, palladium. Next, palladium, barium sulfate, Lindlar's catalyst. So everywhere. So the majority, that is what? D block elements only showing a catalytic property. Next, seventh one, magnetic properties. So magnetic property. Who is responsible for magnetic property? That is what? Unpaired single electron. So not only free electron, that is unpaired. Unpaired single electrons are the responsible. See why that is showing unpaired single electron is what? It is revolving around itself. So any object revolving around itself means a magnetic field is created. So because of this, number of unpaired electrons are increases means magnetic field also continuously is increases. So for D block elements, how to identify that one? The formula is their magnetic momentum. So magnetic momentum mu equal to under root of n into n plus 2 Bohr magnetons. Otherwise, under root of 4s into s plus 1 Bohr magnetons. So S is total unpaired electrons spin you can take. N equal to number of unpaired electrons only. See, by direct how we can identify means suppose in the given compound, in the metal, you identify if unpaired electrons are n, then the magnetic momentum is n.72, n.9 Bohr magnetons. No need to do any calculation. Direct unpaired electrons 1, you put answer 1.7, 2, 2.7, 3 is there, 3.8, 4 is there, 4.8. Unpaired electrons maximum 5. So your answer 5.9. So directly, this is applicable for only D block elements. In F block is more complicated, that one. See, next, if suppose any element that has all electrons are paired, so then it will be showing diamagnetic. So how to identify? Suppose best example you take copper. So copper is what? 3d10, 4s1. So copper oxidation state plus 1 means 1 electron is gone, 3d10. So all electrons are paired. There is no unpaired single electron. So that means what? It is a diamagnetic. Magnetic momentum is 0. Suppose you take Cu plus 2, so that is a 3d9. So one electron you are getting unpaired. So that's why it is showing paramagnetic. So mu value, one unpaired electrons are there. So 1.7 Bohr magnetons. Whatever the example is given, first you identify the oxidation state of metal and you count the unpaired single electrons. So how many unpaired electrons? That 0.7 to that 0.9. Direct your answer. Next, eighth one, we will see color properties. See, first of all, we must know how the color is coming. Suppose you take one object. So one object, you are sending some light. So then what happens? Some light is absorbed and some light is ejected from this. Suppose this ejected light, so ejected light is falling on our eye, so you can visible as a color. So that main basic point of a color. So who is responsible? Suppose we are sending light, who will take that light first? So here unpaired single electrons that will be jumping and coming down. So in the meanwhile that light will be coming outside. So because of that, that outcoming is in VIBGR range, then only your eye will be identified as color. Suppose outcoming is either UV light or IR, so you can't identify that colors also. So now based on this, if you see in our D block elements, so D block elements has 5 orbitals. So in that 5 suborbitals, we have dx square minus y square dz square. Next dxy, dyz, dxz. See x square minus y square. So you take xy. It is present on the axis. Next dz square, z only. X-axis, y-axis, upon z only it is dz square. So these two are present on the axis. On the axis, these are called as EG orbitals, means doubly generated orbitals. So xy, it is between x and y. So yz, it is between y and z. Double dumbbell is between the axis. This is xz, between the axis. So these three you called as a T2G orbitals. These are between the axis. So in the d orbital we have two types. One is d orbital, another one is a T2G. So that's why if ground state d orbital is splitted into two, what? EG orbitals and T2G orbitals. Suppose if light is falling, suppose one electron is here, suppose light is falling, so that light is absorbed by this electron and it is excited to higher level and higher energy. So energy is in this manner. So because of high energy instability, the excited electron is coming back to ground state. In the meanwhile, whatever absorbed light is coming outside as color. So means who is the responsible for color means unpaired single electron. So where in one word you can write means it is EG means d orbitals only. T2G means that is also d orbital. So who is responsible? The unpaired electron jumping from d orbital to d orbital. So in one word you can write the answer means electron excitation from d to d orbitals. So this is the answer. Next here complementary colors will be there. So complementary colors. See, suppose you take our VIBGR. So violet, indigo leaf, next VIBGR. See, here, suppose the substance is absorbing violet color, outcoming is yellow. If yellow is absorbed, outcoming is violet. So that means highest energy absorbed, lowest energy coming outside. If lowest energy is absorbed, highest energy coming outside. Suppose if any substance absorb blue color, outcoming is orange. If a substance is absorbing orange color, outcoming is blue color. If a substance is absorbing red color, outcoming is green color. If substance absorbed green color, outcoming is red color. So this is complementary. Suppose in examination also important, what if substance is absorbing red color, which color will be ejected? So that is your green. Next, ninth one. So that is mixing of metals. So mixing of metals you called as alloys. See, their crystalline structure and their properties are very close. So that's why one element is easily mixing with other elements. They can easily form alloys. So the D block elements only, more and more, they can form alloys. Because of more number of metals, this only. See, so already we are given that shortcut. So in INMAC, nicroy, manganol. So in that, so nichrome. So nichrome means nickel, chromium, iron. Manganese is a little amount. So that is the combination. All are D block elements. Next. So type metal, listen, sold. Next. Gunmetal. So gunmetal, our shortcut what? Gun cartridge. So copper, tin, zinc. Next, bell metal. So bell metal, also bronze. So bell brocati, copper plus tin. Next, invar steel. So invar steel, INMAC. So iron, nickel, manganese, carbon. So that magnesium. So that is extra combination. Next, German silver. So German silver. So Germany kaji, nickel, copper, zinc. See, there is no silver in the German silver. So that examples are very, very important. You can concentrate. So bell metal, gun metal, bronze. Next, brakaji. So that is brass. That is what? Copper plus zinc. So examples are very, very important in the examination point of view.